Hi Mr. Giovantiera, and welcome to this video presentation of the group of Mr. Santos, Mr. Urbino and Mr. Alejandro.
Today, we are gonna see their rubber-powered car in action and moving like a real car rolling down the street.
That's right. But before anything else, let us first discuss the three laws of motion that we are now studying in physics.
The three laws of motion were first compiled by Sir Isaac Newton in his work Philosophiae Naturalis Principia Mathematica, first published on July 5, 1687. Newton used them to explain and investigate the motion of many physical objects and systems. For example, in the third volume of the text, Newton showed that these laws of motion, combined with his law of universal gravitation, explained Kepler's laws of planetary motion. Newton's first law is a restatement of the law of inertia which Galileo had already described, and Newton gave credit to Galileo. Aristotle had the view that all objects have a natural place in the universe, that heavy objects like rocks wanted to be at rest on the earth, and that light objects like smoke wanted to be at rest in the sky, and the stars wanted to remain in the heavens. He thought that the body was in its natural state when it was at rest, and for the body to move in a straight line at a constant speed an external agent was needed to continually propel it, otherwise it would stop moving. Galileo, however, realized that a force is necessary to change the velocity of a body, that is acceleration, but no force is needed to maintain its velocity. This insight leads to Newton's first law: no force means no acceleration, and hence the body will maintain its velocity. Mass is the measure of inertia. Low mass equates to low inertia. The second law states that the net force on a particle is equal to the time rate of change of its linear momentum in an inertial reference frame. Newton's second law requires modification if the effects of special relativity are to be taken into account, because at high speeds the approximation that momentum is the product of rest mass and velocity is not accurate. Net force, or the resultant force acting on a body, produces acceleration that is inversely proportional to its mass and directly proportional to a net force of the same direction. Here, acceleration is achieved through force divided by mass.
Lastly, the law of interaction, or the action-reaction law, states that to every action there is always opposed an equal reaction, or the mutual actions of two bodies upon each other are always equal, and directed to contrary parts. Whatever draws or presses another is as much drawn or pressed by that other. If you press a stone with your finger, the finger is also pressed by the stone. If a horse draws a stone tied to a rope, the horse, if I may so say, will be equally drawn back towards the stone, for the distended rope, by the same endeavor to relax or unbend itself, will draw the horse as much towards the stone as it does the stone towards the horse, and will obstruct the progress of the one as much as it advances that of the other.
If a body impinges upon another, and by its force changes the motion of the other, that body also, because of the equality of the mutual pressure, will undergo an equal change, in its own motion, toward the contrary part. The changes made by these actions are equal, not in the velocities but in the motions of the bodies. That is to say, if the bodies are not hindered by any other impediments. For, as the motions are equally changed, the changes of the velocities made toward contrary parts are reciprocally proportional to the bodies. This law takes place also in attractions, as will be proved in the next scholium.
Newton stated the third law within a worldview that assumed instantaneous action at a distance between material particles. However, he was prepared for philosophical criticism of this action at a distance, and it was in this context that he stated the famous phrase, "I feign no hypotheses." In modern physics, action at a distance has been completely eliminated, except for subtle effects involving quantum entanglement. However, in modern engineering and all practical applications involving the motion of vehicles and satellites, the concept of action at a distance is used extensively.
First, we have prepared you a video that will explain the three laws of motion, further to be followed by the video of the rubber-powered car of Mr. Santos, Mr. Urbino and Mr. Alejandro. Enjoy, Mr. Vieira.